Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Norma Stellar, head of IoT at German Bionic, which is a maker of exoskeletons for industrial and medical applications.
Very happy to be here today with you. My name is Norma Stellar. My job title is head of IoT. I work at German Bionic now for 3.5 years, and basically my responsibility in the company is that I'm leading the electronic and software development teams that we have here. And in the software part, it does include the embedded software, the operating system that runs on our exoskeleton, the AI initiatives that we do, as well as the cloud software that we have to access the data coming from the exoskeletons.
Right, okay. And the company in question is, of course, German Bionic, the maker of the exoskeletons, which you can tell me about in a minute. I've got the website here. I'll try and go to relevant pages as you talk, but give us a brief overview of the company, please.
Yeah, sure. So German Bionic is a company based in Germany, and we also have offices in Japan and in the US. And to put it in a nutshell, we are the first company that is developing and manufacturing smart and powered exoskeletons, especially designed for logistics and more precisely for warehouse use cases. What you see on our website right now is our most recently launched 5th generation of our exoskeleton that goes by the name CrayX. And all of our exoskeletons are powered exoskeletons. That means that they use an external power source to provide the energy that goes into the system, and it helps workers wearing the exoskeleton to lift heavy loads. So it basically compensates the load on the lower back that people don't get injured on the job. And the 5th generation also supports not only the lifting, but also it supports you with every step you take. It has a walking assistant that you can also see on the website.
I find it really fascinating that this technology has become such a talking point. It's aroused a lot of interest from the industry. That surprises me for two reasons. One is that I never really thought about this technology as being a real world technology outside of the Alien film that I saw many years ago, the second Alien, the Aliens film, where Sigourney Weaver wears the massive exoskeleton to fight off the alien. It's a fantastic scene, which I'm sure you'll agree is one of the best in cinema history. But it's a very interesting technology. I never thought it would be something that would interest, real world, I would say, boring industry. A lot of people find industry boring. You and I don't. But can you give us rewind a little bit? Give us a potted brief history of the exoskeleton in industry. When did it first sort of occur to people that this would be useful in manufacturing and logistics and so on?
Yeah, so in general, the whole technology really emerged out of the medical use case, where exoskeletons were designed to help patients to walk again with different medical conditions. So that's basically the origin. And that was also the first time exoskeletons were really into use and helping people. And from that time on, the technology and the components that are used to build an exoskeleton got better and better for the use case. So that means that engines got smaller and more powerful, that materials were designed that can provide a certain lightness to the whole system. And then, of course, the point to moving it from a medical, like a treatment device, to a preventative device that we have is quite short. I mean, the overall thinking is always, we as humans, we have physical weaknesses, and we build us a robot that can compensate those weaknesses. And for the industry, it's obviously very interesting because those guys working there are the ones that doing a lot of tasks still manually, and the load that they're moving is also quite heavy with a high repetition. And of course, the industry first reacted by trying to automate most of those tasks, and in a lot of verticals also very successfully. When we think about the automotive, the car industry, for example, I mean, they basically automate the whole supply chain. But there's still other fields, especially in warehouse logistics, where automation is not really possible. And especially when we think about the rise of e-commerce in the last couple of years, that led to a tremendous amount of workplaces where people are actually moving our goods that we deliver the whole day. And thus the thinking was very easy to say, okay, let's put this technology that is already in use in the medical field to the industrial field. And that's where German Bionic pioneered in, I think, 2016, where they built the first prototype of the system that you see right now. Back then, it was a scientific project. And after the scientific project was done and the demonstrator that was coming out of it was such a promising technology, our founders decided to build a company around it. And since then, we basically iterate the technology from generation to generation. And what's also very important in our product is that we decided 2.5 years ago that we also want to connect our system to the internet. And yeah, we can talk about that maybe a bit later in detail, but that's basically the story. And since then, we are iterating our exoskeleton that it gets more powerful, more lighter, more easy to put on, that we can really provide an ergonomic tool for those people who need it most, which are usually workers in the industrial field, warehouse logistics, construction work, etc.
Yeah, I appreciate you giving me dates like 2016 and 2.5 years ago. So it gives you, like I say, it's a very recent development in a commercial sense. I mean, in the medical field, maybe it's been going on for a couple of decades. I don't know, but certainly in the commercial sense, it's now becoming almost a competitive, quite a competitive space. There are different companies producing exoskeletons, and this is the first time I heard about connected exoskeletons as well. It doesn't surprise me, but I hadn't thought about it. We'll get onto that in a minute. Just for the maybe people who don't know about exoskeletons, a little bit more. Just a little bit more introduction of the device itself. Now, for me, it's been intriguing to kind of figure out when somebody wears this, the heaviness of the item itself is one issue. And the other issue is where does the power come from? I mean, if it was obviously connected to the ground, it could push against the ground and create power through there, through the anti-gravity, if you like, and help me with my arms and back and so on. Where does the power come from in this instance? Is it those little circular things there at the sides? Is that where the so go on.
That's where the drive chain is. So that's where on both sides we have engines, electronic engines. And the whole system basically works sensor based. So we have sensors in the exoskeletons that can detect a certain movement. And this is steering the engines. And the engines have the little leg connectors. As you see, people wear something around their legs with our exoskeleton. And this is basically the place where the exoskeleton pushes you up. And then you have basically the system, the engines give you energy, they push you back from your legs, and this is lifting you up in a nutshell said. And the connection on the body is done via the upper belt system. This can be imagined like a normal backpack. So when you wear a backpack, you have something around your shoulders, around your hip, plus the leg connections. And this gives us the opportunity to put away the strain from the back, and we put it more onto, let's say, rougher or more suited body parts. For example, your upper leg is a very strong part of your body, so we use that as a foundation to push you upwards, and it basically puts you on your shoulders and moves you into the upright position again. So the overall design is really avoiding any pressure on the lower back and putting it more onto your body where you can deal with it better, which is the upper legs and the shoulders, and you don't really feel it. You don't have to, or there should, no one should be afraid that you're being pushed by the system, etc. It's just an assistive system that augments your movement. It doesn't do anything out of your own movement, since it's really listens to your body by detecting your movement. Yeah, I hope I explained it.
No, you did.
Good
You
enough.
did. No, it's excellent explanation. These are basic explanations that I'm only doing because people. It's a new technology, and it's good to cover the basics. I mean, I've done very little manual work in my life. Some in my teens, and some just for fun. I worked in a mechanical in a car garage for a while, and it's a tough. It's a very difficult. Manual labor work is very difficult. I mean, the guys I see working all day, every day, I was helping them for like 20, 30 minutes. I couldn't really cope with the whole hour of it. So you'd be
Yeah.
underneath a car, for example, and you have to reach up into the car, into the engine or whatever you're working with. And just that, lifting your own arms up to that height and doing work is a very difficult thing to do, to sustain for a long time. So that's one thing. And of course, your back. In this instance, your machine seems to mostly support the back. Are there
Yes.
different versions that support the arms, or is that a separate sort of development that may happen in the future?
Yeah, so right now we don't look into the arms that much. There are other systems out there that do support the arms. Those systems are usually passive systems, and that's really a very important distinction between exoskeletons. You have the active ones, like you see on our website, and there's also passive systems, and those systems, they don't have an energy source. You basically put your own body energy into the passive exoskeletons, and then the passive exoskeletons release the energy to support you. And this is, for example, very common in upper arm exoskeletons that help you with keeping your arms up, as you said. This overhead working is one very prime use case for those passive arm exoskeletons. We don't really do that. We are more on the, let's say, more high-tech powered exoskeletons that have this external energy source. And also our thinking is that we really want to add energy into the system. When you think about the person plus the exoskeleton as one system, because the person is wearing it, then we want to provide additional energy. With passive systems, you basically only have the human energy. So we want to provide additional energy that we can also counter fatigue on the workplace as best as we can. And this was also the reason why we looked into walking support, because when we find a way to really utilize the energy of our exoskeleton in different body parts, when lifting or when walking, then we can give a lot of energy back into the system that the person wearing it doesn't have to put in him or herself. That means the energy of the person is saved, that you can maybe after work enjoy your life a little bit better than without it, because you have energy left to go out and play football with your kid or whatever.
Absolutely, yes. A whole generation of my parents' generation, certainly they, and a lot of them worked in manufacturing. Probably more than 50% of people worked in manufacturing, and yes, people are very tired at the end of the day, often doing 6 day weeks and so on. So it's a different world now, and these kind of technologies, I'm sure, will improve the quality of people's lives. It seems that this is a picture of you here, and with your exoskeleton. Yeah, it's a fun business to be in. So tell me a bit more about the IoT. This is something that I hadn't even thought about, the idea of connected exoskeletons. I'll play this video while we're talking. Explain about the IoT element of it, or the connected part of it.
Mm-hmm. So basically, I start with where we came from when we decided to go that path. Before I joined the company, the exoskeletons are still or were still exoskeletons. They work perfectly fine. But we figured that we can even learn more about the market and the usage when we connect them to the internet. And the first thought was really, okay, we want to learn about exoskeletons, we want to learn about the workplaces, and we really want to understand how much strain was put on the people, that we can optimize our product for the market. There's always the challenge when you work in that kind of industry that access to those workplaces is not that easy. I mean, you can do some scientific researches with those companies, and they also let you interview people, etc. But you don't really have long-term data. It's super tough to obtain. And then we thought, okay, why not just connect the exoskeleton? Then we have the long-term data automatically with every single minute it's used, and we can learn how to improve our product for our users. And then later, as we learned more about the exoskeleton, the usage, and the users, we figured, okay, we need to build an exoskeleton that is able to adapt to the people wearing it, because this is really the holy grail of exoskeleton development. You need to make sure that the exoskeleton is comfortable, that when you wear it, and that it doesn't really hinder your movement. It should support you, but it shouldn't block you, or it shouldn't alter your movement. And with that, then we figured, okay, we need to understand much more about movements, and we need to understand much more about movement patterns. And with that idea, then we started to look into the field of machine learning, how we can build algorithms that can adapt to the individual wear very easily on the field and on the fly, that no one has to come to you and let's say optimize the exoskeleton for you. The exoskeleton should optimize itself. So that's basically our thinking. And that's also what we're currently working on, that we really can provide individual exoskeletons without having to build different hardware. Yeah, and of course, we also want to keep our products up to date. So we have basically with everyone has a smartphone, you get updates from time to time. The same happens with our exoskeleton, that we can deliver features to the users, that we can customize the device easily to the use cases and verticals. So we have the opportunity to really allow our customers to make the exoskeletons their own without going there and having to do a lot of manual adaptation. Yeah, so that's basically the advantages of putting it into the internet, I would say.
Yeah, it's if it taps into or is part of this whole idea of what you're doing. Kind of reminds me of another story I'm working on, or learning, a subject I'm learning about, which is in the area of autonomous cars. It's they call it software-defined vehicles. Now, the idea, what you've just basically described is the idea that this is one could argue that it's primarily a software sort of development. This device will send you back data, and you can update the device either individually or remotely in terms of enhancements for the individual user, or maybe general improvements of the device itself. And that's something that it's a different kind of approach. It's a software first approach rather than a hardware first approach. Would you say that's true? And what can you explain to me to help me learn about this whole idea of software becoming such an important part of development or engineering, as it were?
Obviously, since I'm very close to software, I would agree with you that the software part is basically the thing that sets us apart, I would say, from other exoskeleton manufacturers. It's a very key element of our development, since it's also a very wide field of development. We talk about IoT, software operating systems, AI development, etc., which is, of course, requires a very large team to really bring it to life. And because of that, only the software part is a very huge part in our company. But in general, the overall thinking is really that software can be iterated much more easily, and you don't have to put a lot of resources into hardware. This is also because the technology that we use, the engines, the sensor, etc., they are very valuable resources, and it doesn't really make sense to throw them away because there's a missing feature or whatever. We try to deliver those with our software. So this is also a promise to our customers that the devices that they have will be updated very, very regularly, that it never gets old, and that they can all, let's say, participate in our software development success. In general, when we look into the industry, maybe a little bit wider, when we also talk about robotics and in general, or collaborative robotics, obviously the software part is the one that is the most important to really bring those systems into your own ecosystem. And this is probably also the part where most companies still struggle, because adapting robots is still very, very, let's say, challenging. That's why software engineering gets more and more traction, because people want to have custom feature. That's absolutely normal. And that's why you need the engineering capacity to make those customizations happening. And usually in our fields today, those are software engineers. But still, everything is only possible when you have a sophisticated hardware, obviously. So we have a very good balance, I would say, between our mechanical development and software development. But we have the opportunity on the software part that we are able to iterate a little bit more quickly. That's our benefit here.
Yeah, I read an article the other day about how this I don't know whether to call it. Well, I think the word that they used was paradigm. It's a new paradigm. It's a new kind of a setup where often the device that you buy, whether it's a car or an exoskeleton, will improve over time. You know, you start off with the device. It has a basic level of functionality. It learns, as you say, about you as an individual, how to accommodate your movements, for example, and it gets various software updates over time. So therefore, it improves as a product over time, which leads me to think, at what point do you bring out a new exoskeleton? I mean, what constitutes an upgrade? You know, if you're continually making slight improvements through the machine learning, onboard machine learning perhaps, or the ongoing machine learning, as well as software updates, at what point do you say, well, now is the time to launch a new version of the exoskeleton with new software? I mean, you know what I'm saying?
Yeah. So basically the decision is always how can we improve the experience for our customers, for our workers. We call them workers because those are the people wearing them. And here we have key indicators that every single exoskeleton manufacturer is always looking at. First one is the easiness of use. So there is still and always new ideas how we can make it easier to put it on. How can we make it easier for the people to, for example, to customize the different straps, etc. So this is and belt systems. So this is something of importance. We look into new materials. The ones that you see on the website, for example, is now made out of carbon fiber, because we figured along the way, okay, this is a much better material for our exo. Let's use that. Or another reason for the 5th generation that you see here is that we in the software development team figured that we need more power. So we switched from 18 volts to 40 volt battery system, because that gives us much more speed in the engines, that supports walking better. So when we have those features, then we obviously iterate the hardware, because in the end, every software can be iterated for so long, and then you have to find a new platform, for example. And the 5th generation is one of the next platforms that we have. But still, our other systems that are still in the market will get updated as well, because we also need to make sure that the system is secure, and everywhere where you have software, it needs updating. So with every generation, of course, the scope of the software engineering team gets larger and larger. Which is also something that might be the reason why people still shy a little bit away from taking on that task, because you have to be very clever with your iterations, with your software. development cycles and also when you really make the move to put out new hardware. But in general, as I mentioned, we are around for quite some time now, and it's now our 5th generation on the market. So the iteration cycle is kind of very, very quickly, I would say, for hardware, because we learn so much. The technology is still very young, and there's always new materials, new engines coming out that we want to use and try. Yeah, we always have the challenge to find the perfect timing for the next release. But the key indicator is when we have enough feature to really make it easier for the users, then we basically iterate the hardware as well. Otherwise, we do it via software. And for the software development process there, it's really something where we work together with the customers. When they have certain demands and features that they need, then we basically enable them to use them by developing them and also making them accessible for other customers that might have similar use cases as well.
Interesting. I didn't even think of that, the customer-led kind of development. Yeah, so tell us a little bit of a few highlights of what are the capabilities of, I mean, these images I'm looking at, I guess these are the readouts of the data that come in. Yeah, it's very interesting, I'm sure, for people who are your company, who, it's a very clever thing. Is this something, I've got loads of questions, I don't know which one to go to first. I mean, is this something that only you are doing? I can't remember hearing other exoskeleton companies doing this.
To my knowledge, and I'm sorry when I missed someone from our industry here, but to my knowledge, we are the only ones that do it right now with that, let's say with that scale, that every single exoskeleton is connected and every single exoskeleton comes with the software component. But also to be very clear, every single powered exoskeleton, regardless if it's connected or not, does have the software component, because you have to steer the engines, and that's really done with embedded software development, where you figure a way how to interpret its sensors and steer the engines. We just we just use the help of our data for that. So it's not done by a developer. It's basically a data-driven approach. Yeah. Yeah, sorry, just to add there. I mean, we would really like to see more people going into that sphere as well, because the data we obtain from the exoskeletons is very important, not only for exoskeleton manufacturers, but also maybe for other stakeholders here, because we have also very clear visibility about the workplaces itself, and we understand quite a lot about the let's say what kind of superhumans they are. I mean, they are really doing and working tremendous amounts. When we just think about, we have users that are basically getting support by the exoskeleton of around 7 to 9 tons per shift, which is a lot. I mean, this is only the amount that the exoskeleton is really moving. So the person itself is also moving a little bit of those. So that gives you an idea how much weight is really onto their bodies, especially when they don't wear an exoskeleton. I mean, they still have to carry those loads. And when someone is lucky enough to have our the exoskeleton is doing the majority of the work. But we really have to think about those people in a larger, let's say with more. Sorry, I lost my fun here. So really what I would like to say is that having more and more data on those workplaces enables us also to value those workplaces in a different light that we might do it right now, and also give them help to make their lives easier in the workplace. And this is really something we can only do with data. It's no other way to really get insights there. So every exoskeleton manufacturer out there, figure it out. It's not that hard.
Well, you answered the question I was going to ask next, which is what are the capabilities of what superhuman feats could I achieve by wearing the exoskeleton? You said that I could move several tons of items over the course of a day. That's an amazing and impressive thing to be able to do as an ordinary human being, healthy, reasonably healthy as I am. I don't think I could do that. Obviously, I couldn't do that on my own. So yeah, it does give you superpowers. So, all right. So you've been in the market for a little while. Let me ask you, I know you're probably not your area, commercial side of it, but you probably know enough to answer the question of how things have gone for you business-wise. You know, you are in several different industries, construction, obviously we see here, logistics, manufacturing. But German Bionic, as in terms of possibly number of units of exoskeletons sold, or revenues, or any kind of idea that you can give us that gives us an idea of what the business is like for you.
Yeah, so basically, I'm not in a place to disclose any numbers, but what I can say is that when a company is really expanding with offices in Japan and the US, etc., this is usually a very positive side for the business. So we are doing quite well, I would say. In general, the exoskeleton industry, or the numbers of systems in the market, is not that high yet. We do have estimations that they will be picking up very quickly, very soon, because just of the demand of the market here. And we obviously prepare for that. But right now, the technology is still what I would consider in the early stages for breaking through into the masses, really.
Right.
In the end, you always start to work with customers, and you will find some of those on our website, which are happy to disclose the partnership with us. And those customers are quite large already. And those are obviously also, yeah, let's say, I don't know how to say it in English, maybe they kind of multiple the chances here, because they are large customers, and usually smaller customers always look into what larger customers are doing. And so we also hope that when we have a good market fit here, others will pick it up and also consider providing this technology for their people, because in the end, it's a very easy economic decision. Every time you can prevent your workers getting injured or having to replace someone is really saving you a ton of money. And obviously, that does not even come to the point where it's also, let's say, a responsibility to the workers to provide them with the best tools that they can do their job, but also live their lives off the job.
Now, I suppose, towards the end of our interview, one question I have about the instances or examples where a robot could be used, or a situation where either a robot could be used or an exoskeleton. So we've seen instances where people have wearing your exoskeleton have moved boxes from one place to the other. I think that's called depalletizing in
Yes.
some circles. So I've often seen a robotic arm being used for depalletizing. In this instance, obviously, we're talking about an exoskeleton. So there are why would somebody choose an exoskeleton over a robot? What are the pros and cons of, you know, one or two of the advantages and disadvantages? And what kind of, can you think of an instance where a robot just won't be able to do the job? You need somebody a bit more nimble, human nimbleness, flexibility, you know, added to a little bit of power from an exoskeleton.
Mm-hmm. So robots or full automation is always really helpful when you have very strict, very organized, and let's say very long-term plans with your, for example, your factory or your warehouse. And a lot of our customers, they don't really have that. They need a certain amount of flexibility. And they are also customers that expand quickly, and they need a technology that is easy to apply to their warehouses without having to do any setup time or whatever. So there's really where exoskeletons are, let's say, more advantage, or they have more advantage than the normal robot. However, when you have dangerous environments, obviously robots make more sense, because we don't want to endanger people. But in general, every single time when you really think about where's automation and where does the people come in, we want to give you a third answer here, which is, hey, you can use both. Because we still think that humans in their workplace are a tremendous benefit when it comes to problem solving, when it comes to optimizing processes. They are the ones that can give you feedback about making it more efficient, etc. And we just want to provide them with a robot to counter their physical inabilities. So the system is really keep the intelligence of the human, but give them just the power of a robot, and you have the best of both worlds in a very flexible system. So this is really where the exoskeleton could be the third answer. It's not either automation or human labor. It can be also both in the same system. And also another thing where we really are, or where we are very quite sure, is that there's no possibility right now to really have such an intelligent robotic line that can really optimize themselves. I mean, or in other words, when you have a fully automated robotic line and there's a problem, robots don't call robots. Robots will still call the human in to solve the problem. And as long as robots call humans, the full automation will never be possible. That's my personal opinion. And it makes more sense to provide people with those technologies rather than, for example, automate everything and then every one of us sits at home and has nothing to do anymore.
Mm-hmm. Yeah, well, I'd still find something to do. I'd get too bored, I think. Yeah, I enjoy my job, what I do. It's a very interesting area to look into. I've done a lot of different types of journalism, a lot of different types of subjects. This is one of the most interesting. Okay, well, last question. Asking you to maybe speculate a little bit based on your knowledge of software and what you're doing with German Bionic. So you're collecting, if I can simplify it, you're collecting data about movement of a human body, how the limbs are moving. I understand the embedded technology does a certain amount, but you're collecting other data as well, which is making, you're getting a very good picture of how a human moves in particular tasks, if I can put it like that. Now,
yes,
what is the possibility or technical challenges of transferring all that knowledge of human movement into a pure robot that doesn't have a human attached to it? So imagine your exoskeleton has grown into a device which has limbs, arms and legs. Would you be able to transfer all the knowledge that you're collecting now, the data about how humans move, into the new exoskeleton, the one that has arms and legs?
Theoretical, this is possible, by just let's say reversing the data. But let's say in general, that's not really the path we would like to take, because as I said, when you have when the human can do the job, it makes no sense to replace it with a robot that looks like a human, because it will be much more costly in the end, since the robots are not clever enough to really help themselves in certain situations. And of course, we also see I just recently looked into Tesla and their human bot they want to develop, which really looks like a human, right? I mean, it has arms and legs and a head and everything. I would say it's not even, or this is a very inefficient way of building a robot. It would make, I mean, why should it have legs? It can also have, could also look more like a car with tires, etc., which is much better because of stability, etc. So building a robot, or I don't think it's really useful to build a robot that looks like a human being, because we have such a complex movement system that it will be super tough and super expensive to really mimic. And I don't know if there's any system out there that comes close to it. I think there are some people that are really experts when we talk about certain body parts, because they're building prostheses, for example, for people that have lost limbs. We are quite good on that, but building a whole body out of it is something that is technically possible, but it's economically not really sensible, I would say. And for us, it would also be against our beliefs as a company, because we want to keep the person on their jobs. That's really what we would like to do and achieve, and to challenge the idea that robots come and replace you. Our vision of the future is more that robots come to assist you.
Very interesting. I didn't think that that would be a consideration for a company that is developing any kind of technology, really. The idea of preserving the place, the human being's place in industry, it's just not a consideration. But yeah, it's very interesting. But
Yeah,
you're right.
I think just to add on that, I think it comes really from the fact that a lot of people think that people working in those workplaces, for example, in construction, etc., that they don't really like their jobs or whatever, and that they can be replaced. Coming from a working class family, I can tell you that's not really the case. A lot of people really do love their jobs, and they want to keep their jobs because they find a sense of belonging and purpose in life. Why should we come and take it away from them when we have so many humans on our planet? What we don't have is unlimited resources. So why should we bother trying to get the resources and replace us? What is the long-term plan here? I mean, it's a little bit philosophical, but it's also something where we think, okay, let's give them just another idea of robots and humans, just that put them in another context where they're working as one system and not one against the other.
Yeah, no, that's it's fair enough, and I understand. As I say, I enjoy my job. I think you know, it's a very philosophical, long-term idea. The idea that we'll all be replaced. It's just not going to happen. Every time a new wave of technology has come along, it's created a whole new wave of jobs and new industries and so on. It's never really happened that people have, you know, been completely dismissed to
Yes.
never find other jobs. They have found other jobs and other industries. So yeah, it's a. I think we're at a very early stage, relatively speaking, in automation and robotics. So these kind of technologies will find places alongside each other in various different fields. So that's what I'm interested in, seeing how things where things slot in. I found what you said very interesting about humanoid robots being complex, unnecessarily complex. Why would you build a humanoid robot with arms and legs when it's not the most efficient or stable way to get around? That's very interesting, but it made me think of climbing trees and you know, walking over rocks and things like that. That's what we were designed to do as humans. We navigated uneven terrain, climbed hills and mountains and trees and whatnot, and obviously did all sorts of other things like jump and skip and all sorts of other things.
But all of that is learned, right? I mean, that's something that we have to always consider when you have I mean, just imagine how people learn to walk, etc. It's something that we do over a certain amount of time, something like that we train our body to learn about balance, about you know, not run against the tree, etc. It's something that we learn, and this kind of learning is not possible technically right now in that kind of scale. You know, you can always focus on certain things and to build algorithms that, for example, can detect if there's a blockage on the street, and then your car can move around it. But movement is it's much more implicit than explicit, and that's why it will be super tough for any engineer to really let a robot learn how to walk, for example, or how to navigate a rocky field, whatnot. So it's still, I mean, maybe it's possible in the future, and I'm very sure that a lot of clever people are working on that. But it will be, there will be a lot of effort needed to really make it happen. And again, I just want to challenge the idea, why? You know, it's yes, technically it's super interesting. I'm also an engineer. I would love to go into those fields, but in the end, it's always simpler to improve systems that are around, and to improve our body is something that humans always did, and an exoskeleton is just the next iteration there. You have people have you know, glasses, and we have systems where you can improve your hearing, etc. An exoskeleton is just another one of those devices that makes you stronger.
Yeah, well, my answer to you would be not that I'm an expert at all, but the word space comes to mind because you know, space is opening up as an industry, exploration of the moon and Mars, and most interestingly at the moment, asteroids. So Blue Origin, the company that the Amazon owner owns, the rocket company, they bought a company called Honeybee Robotics, and Honeybee is quite well known or developed quite sophisticated systems for asteroid mining. The asteroids are believed to have vast amounts of mineral wealth, rare earth minerals and things like that. So in the next 10, 20 years, I mean, you look, you know, young enough you know, if you wanted to develop into those fields or at least observe them, yeah, these kind of things, these kind of industries may develop over time, and that's where you'd need um, robots. Really, you can't send humans to asteroids, not as far as I know right
Absolutely. I
now.
mean, that's as I said, when you have hazardous environments, robots are absolutely the answer. You know, it's also when you want to clear mines or when you are working into, I don't know, radioactive areas. Obviously, robots are the answer here. We don't want to endanger people to do the
Mm.
job.
Okay, last question. I've seen exoskeletons. Obviously, in films, you see absolutely amazing things, and when you see them, you think that that cannot be. It's just pure science fiction. But I've seen exoskeletons as large as the ones I've seen in the films. I think there's a South Korean company that's developed a gigantic one. Yeah, they do exist. I mean, do you see German Bionic going down that route where you are building fully limbed exoskeletons where you can a human can sit inside it, and it's the human is a fraction of the size of the exoskeleton, but is operating, you know, maybe a 15, 20-foot tall exoskeleton to do maybe construction work, you
Yeah.
know, build, you know what I mean? Instead of cranes, you have a human inside an exoskeleton building a whole house or a building. What do you think?
Yeah. Super interesting. I don't know if that's something where we as or let's say for us in our company we really want to focus on the body areas that we see most endangered, and that is for example the lower back. The downside of this full body exoskeletons are that they are very expensive and there's also very heavy, and you need to have a lot of supervision to really steer them. But I wouldn't say it's not possible or it's not a good idea to go down the line in the future. What I think is a bit more realistic is that we will see exoskeleton enter the commercial markets in some time or another, because they can also provide people, especially in sports, some help to get better in their hobbies. They can also help elderly people to walk with more safety. So they might replace some of those walking assistances that we see. So I think it's more realistic that exoskeletons will move in that area first, and then the sky is the limit, obviously.
Okay. All right, no, I can see the companies flowing across the bottom: IKEA, Stuttgart Airport, BMW, DB Schenker. These are very, very, very big, well-known companies. So German Bionic obviously is doing very well, and it'd be very interesting to see how things develop for your business as well as the technical side of it. So thank you very much for your time and your insights.
Yeah, very happy.
Thank you. Is there
I
something
thank
that,
you.
yeah, you're welcome. Is there something that you maybe want to say that I didn't ask about?
On top of my head, I would also just put another maybe vertical into the discussion that we didn't talk about yet, and that is the whole vertical of providing nurses and people taking care of elderly people with exoskeletons. This is an area which might be also very interesting for us also as a society, since we struggle with demographics in the Western world especially, and we obviously need people to take care about our relatives, and their exoskeletons also make a lot of sense. First of all, the load on the people is very heavy because they have to move other people around. And secondly, this is really an area where you need to keep people on the job, because they also not there for moving them around, but also to give them emotional support and be just there as human beings.
Okay, yes, absolutely, yes. I've seen one or two robots being trialed in those areas as well. It just doesn't seem, it's not right. I mean, it doesn't seem effective enough or complex enough to do the job. So yeah, exoskeletons, I think, would be very good. I agree in that sector. All right, Norma. Well, thank you very much for adding that, and thank you very much again for all your time and insights.
Yeah, very happy about it. Thanks for the talk. Thanks for your time, and let's keep in touch.
Will do, yeah. Let me see if I can.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.